Hello students, in previous lecture we have studied about the enthalpy for different types of physical transformation. Today we are going to study about the enthalpy for atomic or molecular changes. That means the enthalpy heat energy which is related with the atomic changes or molecular changes. First of all, we have to discuss on enthalpy of ionization. Enthalpy of ionization, the name itself indicates that ionization, that means ion formation, and ion formation takes place from atom of elements. For example, see here, sodium atom which having electronic configuration 281, it contains one valence electron. That sodium atom in isolated state, it should be in isolated state, and 1 mole of sodium atom in gaseous state. When it loses one electron, that is valence electron, when it loses one electron, then it forms Na plus, that is cation in gaseous state. And for this process, enthalpy change which is related with this process is called as enthalpy of ionization, or it is also known as ionization enthalpy. And here the enthalpy which is related with this process for cation formation from sodium atom is, that is 494 kilojoule per mole. And here enthalpy of ionization which is always positive, because here to remove electron from outermost orbit of atom, then it requires energy, that is it requires energy to remove the valence electron, that is outermost one electron. Then that enthalpy which is related with this process is called as enthalpy of ionization. Then enthalpy of ionization, that is it is a enthalpy change which occurs when removal of valence electron, removal of outermost electron from 1 mole of gaseous atom at constant temperature and constant pressure is called as enthalpy of ionization. Then see here, it is a enthalpy change which is related with removal of electron, removal of valence electrons, valence electron from 1 mole of gaseous atom of an element at constant temperature and constant pressure, that means without change in temperature and pressure, that is called as enthalpy of ionization. Then here enthalpy of ionization of sodium atom, that is 494 kilojoule per mole. Then see here one more example which is related with that enthalpy of ionization, that is suppose Cl atom which is in also gaseous state, and that Cl atom it should be of 1 mole. Here the electronic configuration of that Cl atom is 287, and here 7 valence electrons are there. Therefore Cl atom which is non-metal, it has tendency to gain electron, it has tendency to gain electron and it gains electron to form Cl minus anion, that is anion formation of chlorine atom takes place, which forms the chloride ion in gaseous state. And here the enthalpy which is related with this process is known as electron gain enthalpy. And here electron gain enthalpy is, that is 349 kilojoule per mole, and here as negative sign is there, that means this process is exothermic in nature, because here enthalpy which is related with this process, that is negative, that means here 349 kilojoule per mole energy is released during this process. See here, that process is anion formation, and here gain of electron takes place by 1 mole of Cl atom in gaseous state, and that is the electron gain enthalpy. See here, and that enthalpy is always negative. That means both processes, see here, that Na plus ion formation, that is cation ion formation from sodium atom, it is also enthalpy of ionization, as well as here Cl minus ion formation takes place from chlorine atom in gaseous state. That process is also ion formation process. But here enthalpy of ionization, which is related with sodium atom, which forms the sodium cation of sodium element, that is positive, and here the chloride ion formation takes place from chlorine atom. For this process, enthalpy which is related is a electron gain enthalpy, and which is negative, the amount of energy which is released here. Therefore that enthalpy, that is electron gain enthalpy, is negative. That is the enthalpy of ionization. See here one more concept which is related with that molecular changes or atomic changes, that is enthalpy of atomization. See here, the name itself also indicates that atomization, that is atom formation. Here for example, chlorine molecule in gaseous state, that molecule, it should be 1 mole, and which is converted it into chlorine atom in isolated state, that is in gaseous state. That means here, see here, chlorine molecule which is converted into atom formation, and enthalpy which is related with this process, which is known as enthalpy of atomization, that is atom formation, that is 242 kilojoule per mole. Then here, what is enthalpy of atomization? Enthalpy of atomization, it is a enthalpy change which is related or which is occurs when 1 mole of molecule, any molecule, 1 mole of molecule in its gaseous state, in its isolated state, which is converted into that is constituent atoms in gaseous state, that is, and here without change in temperature, that means at constant temperature and constant pressure, that enthalpy is called as enthalpy of atomization. Here enthalpy of atomization is always positive because here amount of energy is required to break the bond between atoms. That is here chemical bond, covalent bond which is present between two Cl atoms in chlorine molecule to convert it into chlorine atom, and therefore here enthalpy energy which is required to break that covalent bond in a molecule, present in a molecule to form the atom, and that enthalpy is related with this process is called as enthalpy of atomization. For example, one more example, that is CH4 which is in gaseous state, that is methane, and that methane which having 4 CH bonds, that is 4 covalent bonds are there, and therefore here when that CH4, that is methane molecule, here 1 mole of methane which converted it into carbon atom and 4 hydrogen atoms, and here in gaseous state, and that means it's split into its constituent elements in atomic form, and here enthalpy which is related with this process is enthalpy of atomization, and that is about 1660 kilojoule per mole. That means here enthalpy of atomization of methane gas is 1660 kilojoule per mole. That is about the enthalpy of atomization. Then we will discuss on enthalpy of solution. All of you studied about that. Solution formation takes place that when solute dissolved in given amount of specific amount of solvent. Then see here, for example, NaCl, that substance which is in solid state, NaCl dissolved in given amount of solvent. Suppose here solvent which is water, and here in specific amount of water NaCl dissolved into it, and here dissolution of NaCl in given amount of water. For this process enthalpy is related with this process is called as enthalpy of solution. Then we will discuss on enthalpy of solution by taking few examples on it. Then solution formation process, when solute dissolved in given amount of specific amount of given solvent, and enthalpy which is related with that process is the enthalpy of solution. For example, NaCl which is in solid state, NaCl substance, that is common salt which is in solid state, when it is dissolved in aqueous medium, here specific amount of water is taken here, in which here 1 mole of NaCl substance in its standard form when it is dissolved in aqueous medium, then here aqueous solution of NaCl formation takes place, and here the enthalpy which is related with that process is called as enthalpy of solution. Then here enthalpy of solution of NaCl salt, that is 4 kilojoule per mole. See here enthalpy of solution here is positive, but here enthalpy of solution of any substance, it may be positive or it may be negative. Then see here enthalpy of solution, which is included two steps. Dissolution of ionic compound in water. It consists of two steps. That means it formation of solution of ionic compound. It contains two steps. Let us consider Mx is a ionic compound which is in solid state. That is ionic compound which contains M plus cation and X minus anion. Mx is a ionic compound which is when dissolved in aqueous medium. Then in aqueous medium, first that ions which get separated, that means dissociation of ions of ionic compound takes place here, and when they dissociate in given amount of that aqueous medium or in water, then they behave like a gaseous substance or gaseous ions. And here enthalpy which is related with this process is called as lattice enthalpy. That is known as lattice enthalpy of that ionic compound. And here, for example, lattice enthalpy of any substance, that is always positive. And here lattice enthalpy of NaCl, that is common salt. Here NaCl which dissociate in aqueous medium in Na plus and Cl minus ions, and enthalpy which is related with that process is a lattice enthalpy of common salt, that is sodium chloride. And lattice enthalpy of any ionic compound, it is always positive. And here lattice enthalpy of NaCl, that is 790 kilojoule per mole, that is 790 kilojoule per mole. Then as ion formation, dissociation of ions takes place, then in step second, that Na plus ion, it get hydrated with X molecules of water to form NaH2O X times X plus. That is here that process is known as hydration of Na plus. And here enthalpy which is related with this process is known as enthalpy of hydration. And that enthalpy of hydration which is always negative. Here as well as Cl minus ion in gaseous state, it is hydrated with Y molecules of water and it forms, that is here, and enthalpy of hydration, and here enthalpy of hydration of NaCl, that is ionic compound, NaCl compound, it is about minus 786 kilojoule per mole. That means enthalpy of hydration of NaCl for both steps, it is minus 786 kilojoule per mole. And here we can calculate enthalpy of solution of NaCl, that is here enthalpy of solution included two steps, that is enthalpy of that ion separation, that is lattice enthalpy, as well as enthalpy of hydration. That means enthalpy of solution is nothing but it is a sum of lattice enthalpy and enthalpy of hydration of that ionic compound. Therefore, here enthalpy of solution of NaCl compound, that is lattice enthalpy for NaCl, which is 790, plus here enthalpy of hydration of that Na plus and Cl minus ions of NaCl compound, that is minus 786 kilojoule per mole. Then 790 minus 786, that is 4 kilojoule per mole. That means here enthalpy of solution of NaCl compound, that is 4 kilojoule per mole. There are enthalpy of solution of different ionic compounds which is given in your textbook in the chart. You should observe that chart and that enthalpy of solution. You can make the conclusion that enthalpy of solution, it may be positive or it may be negative, which is depends upon two types of enthalpies, that is lattice enthalpy and enthalpy of hydration. See here, that is value of lattice enthalpy, if it is greater than enthalpy of hydration, then that enthalpy of solution of that ionic compound is positive. But if mere the value of that lattice enthalpy is less than the enthalpy of hydration, then that enthalpy of that ionic compound is negative. That means enthalpy of any ionic compound which is depends upon enthalpy of that hydration of that substance as well as lattice enthalpy of that ionic compound. Then in next lecture we will discuss about thermochemistry and enthalpy of chemical reactions as well as standard enthalpy of chemical reactions, and there are few guidelines to write the thermochemical equations. We will discuss about that in next lecture. Thank you.